Okay, we're going to look at how to solve systems of linear equations in two variables by elimination. Let me remind you that linear equations in two variables are lines, and when you have a system, you have two lines, and the solution to that system is where the two lines touch, any ordered pair where the two lines touch. So algebraically, we can solve systems by substitution or elimination. Today we look at elimination. It's also called the addition method. Okay, so let's begin with a system. Here's a system of two equations, and the elimination method is called elimination because what happens is we eliminate the x variable or we eliminate the y variable so that we're only left with the other. So in this case, notice that the x's are lined up, the y's are lined up, and the numbers are lined up. We typically want the form of our system to be this when we want to solve by elimination. The reason is what we eventually do is we add the two equations together to get a new equation. So what happens is if I add the first and second equations together, it's easy to do because everything's lined up properly. X plus 5x is 6x, 2y minus 2y is 0, so I don't need that on this side, equals 8 plus 4 is 12. And so you can see what happened. The key here was that one of the y's was positive 2 and the other y was negative 2, so that when we add them together we got 0. So that's why it's called elimination or addition. We add them together, one of the variables eliminates. Now we know that the x-coordinate for the ordered pair is 2. Now we need to figure out the y-coordinate for the solution. So we take the x-coordinate of 2 and plug it in to the first equation for x or the second equation for x. It doesn't matter, because this will be a solution for both of these equations. So I'm going to plug it back into the first equation, and I get 2 plus 2y equals 8. Subtract 2 from both sides, and divide by 2. We see that y is 3. So the solution to the system is the ordered pair x comma y, so the ordered pair is 2 comma 3. So this is the ordered pair where those two lines touch. Here's another system. This time the y's are lined up, the x's are lined up, and the numbers are lined up, so it's in the form we need. The difference is this system, if I add them together, 6 plus 4 is not 0, so the y's won't eliminate, and negative 4 plus 6 is also not 0, so the x's won't eliminate. So this system will take a little bit of work before we can begin. So what we need to do is make the 6 and the 4 the same number, but one's positive and one's negative. For example, if I could make the 6 a 12 and the 4 a negative 12, then 12 plus negative 12 would be 0. So that's what we're going to do. I'm going to take and manipulate both equations by multiplying both sides by a number. So the first equation, I will multiply both sides by 2, because 2 times the 6 will give me a 12y. And the second equation, I have 4y. I need that to be a negative 12y, so I'll multiply both sides by negative 3. Which will give me a negative 12y when I rewrite it. So I end up with a new system, 12y minus 8x equals negative 4 whenever I multiply everything by 2. When I multiply the second one by negative 3, I get negative 12y minus 18x equals negative 126, and there's my new system. Now I can add the two equations together. The y's will be 0y. Negative 8x minus 18x would be negative 26x, and negative 4 plus negative 126 is negative 130. Divide both sides by negative 26 and we get that x is 5. Now I need to take my 5 and figure out what my y is. So I'm going to plug 5 back into one of the original equations. So I'm going to plug it into the second one. It doesn't matter again. When I do that, I get 4y plus 6 times 5, because x is 5. 6 times 5 is 30, equals 42. Subtract the 30, and divide by 4, and I get that y is 3. So the solution to this system is the ordered pair x is 5, comma, y is 3.